Hello friends, this side Dr. Rahul Pethe. As we already discussed about that IoT, then Arduino, and few things about that, how to upload that data on a cloud. So few more activities we are going to do by using different sensors. As we already discussed about the different sensor, temperature sensor, humidity sensor, touch sensor, pressure sensor. These are the different sensors that we already discussed about the basic information about that. Then how to connect that particular sensor with the NodeMCU or the Arduino. So we'll start with the Arduino. We'll start with the NodeMCU or as well as with the Arduino. How to connect that Arduino or the NodeMCU with the different hardwares. I mean to say that different sensors, which type of sensors are there, which pins are get connected with that particular sensors, and then how to get the output either on LED or on LED, display, that is 16:2 display, or it can be uploaded on the cloud. So this is a startup, how to get started with the NodeMCU. What exactly mean by NodeMCU? What is the purpose to use a NodeMCU? What is the drawback of Arduino? And how to eliminate that drawback by using NodeMCU. So this is the pin configuration or the pin out diagram of the NodeMCU. As we see here, this is nothing but your Wi-Fi module, and in this Wi-Fi module we have a 2.4 gigahertz frequency with the 802.11b/g/n IEEE standard bandwidth. So this is, here we have a different GPIO pins, general purpose input output pins. That general purpose input output pins basically are divided in analog and the digital. We can connect analog sensors or the digital sensor. With that we also have a transmitter pin and receiver pin, that is TX and RX pins. With that, it's also we have a serial clock, serial data, multi input, serial output, multi output, serial input, chip select pin, 3.3 volt pin. These are the different pins we have, and that particular pins are get used for getting connected with the different sensors as an input or output. So as per the as per the pin configuration, if we are going to connect NodeMCU or NodeMCU 8266, okay, so which type of NodeMCU we have to select, and then how to connect that NodeMCU. These are the point we that is in our mind, and that data is uploaded on a cloud. The NodeMCU is open source software and hardware development environment that is built around a very inexpensive system on chip SoC called as ESP8266. In the NodeMCU, we can say that the ESP8266 can be controlled from your local Wi-Fi network or from the internet. For that purpose, we have to connect that particular your NodeMCU with your hotspot or local network, through which we can upload the data. For that purpose, we required SSID as an ID of your network in internet, and the password. If we need to upload that data on a cloud, so we have to upload it on a different API open source cloud, for example ThinkSpeak or the Blink, through on which we can control the device, home automation, agricultural purpose. These are the devices we can control. So it consists of a circuit board which can be programmed via Arduino IDE software. So this is again Arduino IDE software can be used same for the NodeMCU itself, as we already discussed in Arduino itself, Arduino Uno. So this is a similar kind of programming language or programming concepts used in NodeMCU, as we already discussed in the Arduino Uno. But basically few things we require to modify in Arduino IDE software. Arduino IDE is integrated development environment, is a software tool which can be used to write and upload the computer code to the NodeMCU 8266 circuit board through this connector. So as we have a type C or type D, few different NodeMCU we have, so we can connect through this particular connector. So that's simple. We have to install USB driver for the connecting NodeMCU to your laptop. So installing steps are, we can say that on our laptop, open your web browser and type the following URL, as we have seen this URL, and then just install that particular download VCP link of the download CP20X USB to UART bridge VCP driver, appropriate to your operating system. For example, if your operating laptop run Windows 10 operating system, please select the driver circuit from the download for Windows 10 universal section. Similarly, for other operating system, Mac, Linux and other operating systems it have. So Windows supported such type of feature, so it can be easily connected, and by using that we can just download means we can once the driver zip file download on your laptop, open the zip file and double click on the that CP2210X VCP installer, that is for either 64 bit .exe file or ATX .exe file, as it is appropriate for as per your laptop convenience, and follow the step by step. You'll need to need administrative privilege on your computer to install that driver. If it is not, then it is directly installed. So if it can be it is already installed, then we can do one thing. We can just connect the USB cable with the NodeMCU through to your laptop through USB cable itself. So use the micro USB cable to connect your NodeMCU board to your computer USB port. So this is nothing but your micro USB cable. After that, download the Arduino IDE software. How to download that Arduino IDE software? As it is simple. Arduino IDE is a software tool using which we will write a software program or code that can be uploaded to the NodeMCU ESP8266 microcontroller. Please download and install Arduino IDE on your computer through arduino.cc software, where we have to just click on the software option. Again, we can download that particular software through Arduino site. Select the window application. If your laptop is Windows 10, again we have to download that particular Windows software for that window application itself. If it is Linux based, if it is Mac, and the different options are available, you can download that options through your laptop through your web browser itself. So if you can also copy the Arduino IDE installation file by pen drive itself. Please check the facilitator, those who will provide such type of we can say that software. So configuration Arduino IDE software is nothing but connect your NodeMCU to your computer using USB cable. Then open Arduino IDE software on your computer. After opening that particular file, click on the file and then preference menu option. As we see here, we have this particular Arduino IDE software. We can click on the file and then we can click on the preference. Then we can see here this is the option is available in front of you. So as it is available in front of you, so in the preference window, go to the field additional board manager URL, additional manager URL, that we can see that additional board manager URL. As we pasted that particular Arduino link which is available here itself, type the following text, and this is the complete link, and that is we can paste it here, and then just click on the OK, save and close the window. We can just will press on this particular OK button, and then this will get close this particular window. After closing this window, what we can do, we can click on the tool, we can select the board and the board manager. We can see here, we can just click on the tool, then we can go to identify the board, which type of board. As I already downloaded that particular board in my particular laptop, so we can click on the board manager. In the board manager, we can see here, we can open the new window, and this in this window we can just type the particular link, that is nothing but your we can say a board manager. Select the search for the ESP8266. we can see here, we can just click here and we can write it down, ESP8266. So ESP8266 is already installed in my laptop, so no need to download again. Otherwise we can update this particular software. Otherwise there is a a tab is there, so we can just install it. If it is installed directly, then we can check tool, we can go here tool as it is already installed, then it takes some time. We can just click on the ESP8266 by it family, that is we can click on the install. Then after that, what we can do, we can just close this window, as I already closed this window, and then we can check out whether that particularly file is already installed in my laptop or not. and then after that I have to check that particular board is available. ESP8266 board is available, and out of which we can just click on the NodeMCU 1.0 ESP12E module. So this is the link where we can just get the configuration or the connection with the particularly NodeMCU. So after that, as we see here, we can just click on the tool again. We can click on the board, then NodeMCU 1.0 ESP8266 ESP12E module option. Then click on the tool button. As I see here, if I will connect this particular NodeMCU with my laptop, then that port button will get active. Now it is inactive because I'm yet to connect that particular NodeMCU with my laptop. If it is connected, then port will get active. If port will get active, then port number will get indicated on that particular port option. So you can choose that particular port option and just click on that particular port number. So we can see here if it is get connected, then there are multiple libraries or multiple sensor we can connect. So we can see here, we can just click on the sketch. As we see here, we can just click on the sketch and we can include the library. We can see here, we can add the libraries, different libraries. We can add whatever the sensor or the whatever the hardware we have to connect to your hardware, means NodeMCU. So click on the library manager. Then we can just window search for the Adafruit unified sensor, whatever the sensor we have to just connect. As I see here, I can just click on the sketch. I can just click on the include library and then manage library. If I will click on the manage library, one more window has been opened. That window where we can just install the different hardware or the sensors details. So it will take some time as per your configuration of your software, and then that time it should be connected with your internet itself. So I can see here if it is available, then we can just close the window. If it is not, then we have to wait for the some time. We can just open that particular library manager. This is the new window, it is available, and then after that we can just click on this particular tab and then just write it down whatever the sensor we need to connect with your hardware. So here I can say that Adafruit, F-R-U-I-T, Adafruit DHT, I can say DHT11. So if it is installed already, then no need to install. Then just update that particular file. It takes some time to install that particular file. So Adafruit DHT11, as I see here, there are multiple Adafruit DHT11 hardware is available, or that particular file is available, out of which we have to select properly Adafruit DHT11. This is DHT11. So if it is not available, then I have to install. So I can just click on the install, then install all. Then it is get started to install in my Arduino IDE software. Means that particular hardware or the sensor libraries is included in my that particular library file, where I have that particular folder, that is nothing but your Arduino IDE folder. So once it is installed, then you just click on the close of this particular window, then it will get closed. It takes some time to install that particular file. So after closing this window, we can see here, we can just write it down the program. So there are two steps to write the program. One is nothing but an initialization, and second is nothing but a void setup, and second is nothing but your to do a particular task. Means whatever the pin is working as an input or output, we assign the task to that particular pin. As we see here, this is already it is installed. As we open the new file, then this particular window is open. As it is open, then we can see void setup file, where we can put your setup code here to run the ones, and this is nothing but your void loop file, where we put your main code here to run the repeatedly. There are multiple examples are available through which we can just click on the one example, that is blink example. It already discussed in previous lecture itself. So I can say here I can just click on the blink example. So we can see here we have a void setup and void loop. In void setup, we can just initialize the digital pin as an if I need to connect the LED as an output. I just want to click that blink that LED for particular duration, for particular time. So we can mention that initialize the pin by using pin mode. This is case sensitive language, so we have to maintain the particular capital and small letter case sensitive thing. So pin mode, here we can observe that M is capital, pin mode M is capital, then LED button in as an output. So we can say that we can mention that it initialize the digital pin LED button as an output. So we can initialize here in the void setup loop as an output, LED work as an output. Then in the void loop we can write it down, LED work as an either it will get high or it will get low. So digital write, if it is output then we can write it down digital write, and if the particular pin or the sensor is work as an input then it should be a digital read. So whenever we'll assign the task, we can identify that particular pin work as an input or output. If it is input then work as a digital read, and if it is output then it will work as a digital write. So here we can see here digital write, because your pin mode LED is working as an output. And if the sensor is analog, then we can write it down analog write or analog read. So by replacing this particular digital word by analog, so we can see here, if we'll connect the analog sensor, then we have to write it down as an analog write or analog read. Analog write mention as an that particular pin is work as an output pin, or that particular device is work as an output device. And digital write indicate that the device is digital or the sensor is digital, work as an input or output. Write indicate as an output and read indicate as an input. Here as we mentioned that the LED is working as an output, so we can write it down digital write. Again it is a case sensitive, W is capital, remaining alphabets are in a small letter. So digital LED pin working as an output become high. High indicates LED will become on, LED will become on, LED on, turn on the LED. High is the voltage level, like it will become logic 1 or logic 0. So high is become logic 1 and low is become logic 0. So that particular LED will become on for particular duration. So we can mention the delay. So delay we can write it down as an 1000. It means it will become 1 second. It is indicate that the 1 millisecond multiplied by 1000 is nothing but a 1 second. So LED will get on for 1 second. Then after 1 second we have to write it down the instruction to that LED work as an output will become off after 1 second. So we can write it down again digital write, as we mentioned in the first line in the void loop, okay, as a digital write as a high. Now after 1 second we have to it will become low. So for that purpose we have to write it down digital write. Write why? Because it will work as an output. So the LED button become low, so LED will get turned off by making the voltage low, means low voltage, it indicate that logic 0, and then it will become low for a particular 1 second. So for 1 second I have to write it down as a 1000. If I need to make it as a 2 seconds, so I can write it down for the 2000, so it will become 2 seconds. So it is a part, and then the parenthesis will get closed as it is open in the void loop, though it will get closed at the end. Here itself, as in the void setup where we initialize the pin as an input and output, so we can just open the parenthesis and close the parenthesis. So after that particular configuration as we mentioned here, so we can see here void setup, here we can maintain as an pin initialization as an input and output, and in the void loop we can turn on the LED by making that particular pin as an input or output. We can write it down the instruction as a digital write as an output and digital read as an input. The digital, it indicates that particular device is connected with the digital pins, as per mentioned in a pin configuration. We have a digital pin as well as the analog pin, so we can connect. So the blue LED or the green LED or the red LED, whatever the LED we connected to the ESP01 module is connected to the GPIO pin, GPIO general purpose input output, which is also TXD pin. So we can use a serial print at the same time. So we can write it down that particular pin as become on and off. No, so we can write that particular code and upload that particular code through connecting that NodeMCU with your laptop. That particular code will get uploaded by using, we can see here, this is we have a particular software. We can check that compilation. Compiling, it means we can just check that particular code through your laptop itself. If there is an error, then it can be shows the error. And after compiling this particular code, what we can do, we can upload. For uploading, we have to connect that particular NodeMCU with your laptop, and that time if it is connected, then port will get activated, and that port, whatever the port will get activated, then it is mentioned here itself through tools, through port. And once it is get activated, as we see here, compiling process is going on. As it is get compiled, then we can see here it indicate that the compiling done. As it is in process, we can see here it is in process. As it is get finished, then it can show that compiling done. After compiling, we can upload the this particular program by connecting NodeMCU to your USB pin through micro USB to the NodeMCU. After uploading, compiling and uploading, we can check that particular LED will get on and off for 1 second. It will get automatically on and off. So we can make different connections. So in future itself, we can do one thing. We can just connect different sensor, for example touch sensor, for example TST11 sensor. These are the different sensor we can connect, and we can check it out their data either through LED as an output, or we can check it out their data on a cloud itself. So this is compiling process. It takes some time as per the configuration of your computer or the laptop. And once it is get done, so you can just upload by using this upload button, and we see here upload button. So after compiling done, we can just upload that program, whatever the program we have through your laptop. So this is the thing. So we can see here after compiling this, upload button is get activated. Means this is nothing but an upload button. As you see, file, edit, sketch, tools, helps, this is the menu bar, and then we have this is compiling bar, and this is the upload bar. This is new, and then this is the up and arrow and down arrow. We can see here up arrow is nothing but an open, and down arrow work as a save, and this is nothing but a new. We can see here done, compiling will get done. So this code is correct. Now we can just run this upload this particular code in the NodeMCU. So this is simple configuration of NodeMCU, which is nothing but your Wi-Fi based device, and it have the digital pins as well as the analog pins. We can also have SCL SDA. It work on a 2.4 gigahertz Wi-Fi module. 802. IEEE standard is 802.11 BG and N. So this is all about the NodeMCU. Just it's information about the NodeMCU. In next lecture, we can just connect the different sensors, and we'll do the different activities by using NodeMCU. Thank you very much.